When we're asked to find all of the complex roots, this is really not a different question than what we've been asked in the past. We're just being asked to find all of the real and imaginary roots. And unless you happen to notice that there's a pattern here, and this is actually a factorable polynomial, you're probably going to start by listing the p's and q's. So if we look at the p's, we're looking at the factors of 18, including plus or minus 1, plus or minus 18, plus or minus 2, plus or minus 9, and plus or minus 3, and plus or minus 6. And then you'll look at the q's, and you'll be glad to see that a is 1, so we just have plus or minus 1, which makes the list of p's the same as the list of p over q's, and now we know what our possible rational roots are. Going to our graphing calculator, you would type the equation into y1 to do the cheat of figuring out what's the possible rational roots. When you take a look at the graph, you can see it looks like it crosses at some whole numbers. So it looks like we've got -3, looks like we've got 1, and it looks like we have +3. And all of those numbers appear on our list, so that seems promising. It also looks like there's a chance that there's a bit of a change in the curve happening at 1, which suggests that maybe that factor might have some multiplicity, but we don't have a guarantee. We should just be on the lookout. So if I take that graph and I put it right here, I can use my little cheat that it looks like we're dealing with -3, +1, and +3. Personally, I would start with +1. It is the simplest thing to divide by. So as we're setting up our synthetic division, we're going to be able to start with an easy number. So I would say 1, and I would pull my coefficients of 1, -1, -7, +7, -18, and +18. Doing this synthetic division, we see that we do come out with a remainder of 0, which confirms our suspicion that 1 was one of the solutions. Then I would try 3 because 3 is a positive number, and positive numbers are a little easier to divide by than negative numbers. So again, we're going to do our synthetic division. And once again, we see we get a remainder of 0. We've confirmed our suspicion. And that leaves -3 to try, and we'll see where we're at with the remaining factors. So we'll do synthetic division one more time. Now, we've CR0, so we've confirmed all 3 of these solutions work. So we've got x equals 1, x equals 3, and x equals -3. Now, I had mentioned it looked like maybe we had a wiggle going on at 1, but when I look at what's left, I see we've got x squared plus 2 as the remaining factor, and since I can tell that that's going to have imaginary solutions, I know there aren't any multiplicities there. So I'm going to set x squared plus 2 equal to 0. Of course, I'm getting that from the constant, linear, and quadratic terms right here in the remaining factor. And that would let me subtract 2 from each side to get x squared equals -2. And when I take the square root of each side, I see that I'm going to get that x is equal to plus or minus I root 2. So we do in fact have 5 solutions, just as we might expect. So we've got x equals plus or minus I root 2, as well as the 1, the 3, and the -3 that we found through our work. Taking a look at number 6, we're asked what are the zeros of f of x equals x to the 4th plus 2x cubed minus 4x squared minus 7x. And there's a little note here, remember the zeros of a function are the x values that make y equal to 0. In other words, this is the same type of question as the question up above. What are all of the solutions? So we're going to start out the same way we did before by creating our list of p's and q's. So when I look at my p's, that's all the factors of -2. So that's plus or minus 1 and plus or minus 2. When I'm looking for the q's, again in this case the a value is 1, so that's plus or minus 1, which tells me that my list of p over q's is really quite short, which seems a little strange since I've got a power of 4 and I'm expecting 4 solutions. So we're going to take a quick look at the graph to see what we can narrow this down to be. So just as we've done in the previous problems, we're going to enter this equation into y1 and take a look at the graph. When we do that, we can see one pretty clear x-intercept. It looks like it's crossing at 2. And here it looks like maybe it's crossing at -1, but then I see some unclear x-intercepts. I see an x-intercept over here. It looks like it's between -2 and -3, and another x-intercept between -1 and 0. So although those look like real solutions, they may or may not be rational solutions. In fact, I'm pretty sure that they're not, since my only options, looking back at my notes, are integers. So I must have some irrational solutions coming from there. So taking a look at this graph, I'm going to identify -1 and +2 as being numbers I should try. It's a bit of a toss-up whether -1 or +2 is easier here. I'm just going to try -1 first. So doing my synthetic division with my coefficients, I'm going to bring down the 1 and then multiply the -1 times the number and then add down each column to work my way through and see if I end up with 0. And it looks like I do. So I'm on the right track. I'm now going to divide by the 2 with what's left. So I'm continuing my synthetic division, but each time I have a little bit less work to do on this synthetic division because I have one fewer number to deal with than I did before. And again, it confirms that we're right. Now, as we look at this, this leaves us with x squared plus 3x plus 1, which we need to set equal to 0. And we have the heads up that these are going to be irrational solutions, which means I already know that this is not going to be factorable. Since I can tell that I've got irrational solutions, since I've got things in between integers and only integers on my list of possible rational roots, I know not to bother to try factoring and to go straight to the quadratic formula. So I have x equals the opposite of b plus or minus b squared minus 4 times a times c, all divided by 2a. With -3 plus or minus the square root of 5, I am quickly confirming that I have two irrational solutions. There's absolutely nothing I can do to simplify that particular option. So, knowing I'm looking for 4 solutions, I have these two, as well as the -1 we found, and the 2. Those are the 4 numbers that will create a y value of 0.